Congratulations! You survived the 6-month journey and somehow managed not to turn Starship into the most expensive firework in history. You are now officially an interplanetary pioneer. Welcome home! There's just one problem. This place sucks! Let's be real. Landing is just the prologue. Elon Musk wants 1 million people on Mars by the year 2050. But right now, the reality check has hit. Space is hard, and the calendar is slipping. When you step onto humanity's second home, you realize there is no infrastructure, no liquid water, and your Wi-Fi router is currently 140 million miles away. Before we get to the luxury Martian condos and Cybertruck racing, we have to talk about the absolute nightmare of basic survival. To build a civilization here, we are going to need a massive robot sweatshop, literal ice castles, and some deeply questionable medieval chemistry. Since humans are too squishy to survive early Martian construction, Elon's side hustles are finally coming together like an Avengers movie. SpaceX isn't sending astronauts first. They're sending a silicon labor force. Hundreds of fully autonomous Tesla Optimus robots will land first. Why? Because robots don't need to breathe. They don't complain about the lack of Starbucks. And if they get fried by cosmic radiation, you just order replacement parts from Texas. Their first job is incredibly tedious, but absolutely critical: automated mining. They will deploy downscale drilling rigs inspired by the Boring Company. But instead of digging traffic tunnels under Los Angeles, these rigs will be hunting for the holy grail of Martian survival: underground glaciers in the Arcadia region. Every single gram of Martian soil, or regolith, that they dig up won't be wasted either. The robots will process this dirt, mix it with binders, and pave it into flat, hard landing pads. Why pave the driveway? Because Martian dust is jagged, static, and gets into everything. If you don't build roads, the next Starship landing will kick up a dust storm that sandblasts your entire base into oblivion.
Hey, Elon, how about all of this?
Why Arcadia Planitia? Because it's a flat plain near the equator with huge slabs of pure water ice sitting just 10 to 15 feet beneath the surface. Water is the ultimate cheat code for space travel, but the robots aren't digging it up so humans can have ice cubes. They are mining it to solve the biggest problem we highlighted in our last video: the rocket equation. You see, because rockets are so heavy, you need fuel to lift them. But that fuel has its own weight, so you end up needing fuel to carry the fuel that carries the fuel. And Starship is a thirsty beast. It runs on liquid methane and liquid oxygen. Bringing enough fuel from Earth for a round trip is mathematically impossible. Your rocket would need to be the size of a mountain. So Starship has to pack light and make its own gas on Mars. Here is the actual science. The robots will use NASA's Rodriguez well system, drill a hole, pump heat down to melt the underground glacier, and suck up the liquid water. Then, using solar power and compact nuclear reactors, they run that water through electrolysis to split it into hydrogen and oxygen. Next, they take that hydrogen and mix it with the Martian atmosphere, which is 95% carbon dioxide. They shove it all into a chemical reactor, and thanks to the Sabatier reaction, you get pure methane and more oxygen. In other words, we are literally turning Martian air into rocket fuel. This means the first factories on Mars are essentially just automated gas stations. For 2 whole years before humans even arrive, these robots will be grinding, pumping, and filling massive storage tanks. It is the cosmic equivalent of the bring your own cup policy, except if you forget your cup, you are stranded on a dead planet forever. By the 2030s, the first human colonists arrive. And no, you won't be living in a sci-fi glass dome. If we built a giant glass structure on Mars, cosmic radiation would fry your DNA like a cheap microwave burrito. Instead, NASA's Langley Research Center proposes ice domes, using an inflatable core covered in a thick layer of frozen Martian water. Ice keeps the heat in and stops deadly cosmic rays cold. Hydrogen-rich materials like water are surprisingly good radiation shields. But for permanent heavy-duty factories and labs, we need something tougher. We need concrete. But how do you make concrete without hauling millions of tons of material from Earth? Scientists at the University of Manchester found the answer, and it comes directly from the colonists themselves. It's called Astrocrete. To make regular concrete, you need a binding agent. On Mars, the perfect binder is urea, a compound found in human urine. When you mix urea with Martian regolith, it creates a material that is actually stronger than the concrete we use for skyscrapers on Earth. It sounds wild, but medieval stonemasons used to mix animal blood and urine into their mortar to make castles extra sturdy. So, if it was good enough for medieval fortresses, it's good enough for your Martian bedroom. The future of interplanetary architecture is literally held together by astronaut pee. But while building shelters out of recycled wastewater is a neat trick, a self-sustaining city faces a much more dangerous, silent enemy when it comes to food: the soil itself. In popular fiction, growing crops on Mars looks like a simple matter of adding fertilizer to the dirt. In reality, Martian regolith is fundamentally toxic. It is heavily laced with perchlorates, heavy chemical salts containing chlorine. On Earth, we use similar compounds in rocket propellant and industrial bleach. For a human, consuming even trace amounts of perchlorates completely cripples the thyroid gland, shutting down metabolic function. For plants, it's a death sentence. It destroys the cellular structure and wipes out the microbes necessary for roots to absorb nutrients. To feed 1 million people, we cannot ship billions of tons of Earth soil. Instead, the colony must establish a massive chemical processing industry just for agriculture. The soil must be thermally treated or heavily washed with processed water to break down the perchlorates into harmless chlorides and oxygen. Only after this intense chemical scrubbing can the soil be mixed with organic material to create a viable ecosystem for crops. It is a strict, zero-error chemical process. Thanks to this massive scientific effort and the relentless, non-stop labor of the Optimus robot swarm, human survival on the Red Planet transitions from science fiction to actual agriculture. The very first crops harvested here won't just be a psychological victory. They will be the cornerstone of Martian survival. By cultivating protein-rich crops like soybeans and starchy carb-heavy potatoes, the early colonists will finally secure the vital macronutrients needed to keep a human city alive. Alright, so we have potatoes, which means we have chips. At this point, the whole Mars mission depends on one crucial question. Who's bringing the beer? Your carbon dioxide becomes a rocket fuel. Your sweat becomes your morning coffee. Your urine builds the fortress walls. And the clean treated soil grows your food. It is not glamorous. It is a grueling, high-tech, zero-waste grind. Elon Musk's dream of a city on Mars by 2050 isn't just about exploration. It's a profound philosophical act of becoming more than we are. It's humanity stepping beyond the cradle of Earth to expand our existence, create new meaning, and prove that we refuse to accept limits in an indifferent universe. The Red Planet is a mirror that will show us who we truly can become. While SpaceX figures out how to turn robots into miners and wastewater into infrastructure, you have just enough time to smash that like button, subscribe, and leave a comment. Stay curious, and I'll see you on the next planet.